So let us consider the survey data analysis and how we can do missing data imputation in the context of survey data analysis. So let us consider that we have our entire dataset, but we are going to restrict our analysis to these variables only. So I have this weight variable, ID variable, and then this survey feature variable. Some of the variables that are going to be covariates in here. This is the outcome and this is the exposure, say for example. In that case, I do my plot missing, and I can see that diabetes, BMI and cholesterol are associated with various number of missing values. And I can also do the pattern and I can see that cholesterol is associated with a lot of missing, BMI as well, diabetes some. In terms of imputing, let me just use the mice package using the 5 imputations and 3 iterations, and I set the seed, and you can see in here so I have diabetes, BMI and cholesterol, but diabetes was so little amount of missing values that diabetes variable was not really being imputed. Only the BMI and cholesterol variables were being imputed. Alright, so in that case, when I'm creating the binary variable for the cholesterol depending on a particular cut point, and I can do that after the complete function can extract the data, and in that data, entire data, I can create the new variable. Remember that in the entire data looks like this, that the imputation basically creates all of the data in such a way that all of the data are stacked together. Then this is the imputed data that has all of the data at once, but I can separate the data by the imputation index or .imp, and by that I can create a all imputations list using this imputation list function. And in here, if you have like 100 imputations, then you have to write the code 100 times, right? So that is not so efficient. One other way could be to just create the variable first in the analytic data and then use the mice function to create the imputations. Note that I'm not using the mice directly, I'm using Perl mice, which is a parallelized version of mice, and now I'm using more iterations and 5 imputations imputation data, and then I can again use the imputation list function, but this time I do not have to use the for loop that I was using here, not the for loop, but I don't have to subset the data every time. So that gives me my all imputation, which is basically a list, and you can see the list in here. And then how do I do logistic regression? To do a logistic regression, what I need to do is at first I create the formula and then I create the design. Notice that in the design I am using all imputations as the data. What is this all imputation? All imputation is the list that contains all of the data. So I had how many imputations? I have 5 imputations. All of those 5 imputations are in this data as a list. Alright, so after that I just include that list of all of the 5 data sets in my survey design, and then I can basically use the with function to run my model, and this will give me my fits that will contain all of the model fits. That means in total I have 5 model fits from the 5 data sets, and I can extract each of the coefficients separately if you, or even confidence interval separately. But I think the main idea is that we will pull the estimate. To pull the estimate from a survey data, we need to use the MI combine from the MI tools package, and then that gives me the summary of the beta coefficient and the confidence interval, and you can essentially get the odds ratio by simply exponentiating them. And if you want to calculate the confidence interval significance and things like that, you can create convert all of the object in this way and create a matrix that will give you the odds ratio of diabetics 1.47 instead of the log odds ratio. Alright, so far the system that we have seen is that we have created one data, and from one data I can simply use the survey design to get all of my estimates and we can pull them together. There is a second process by which I can get my estimates. I can simply extract each of the data one at a time, and I can use the for loop to create my data set. So this is the all imputation data set, and I'm just extracting the first data set, and then I run the model on that first data set only, and then I create the design on that first data set only. Based on the first data set, I'm creating the first design, and then I'm basically using the first design to calculate my fit. And similarly, I do it for the second data, do it for the third data, do it for the fourth data, do it for the fifth data, and I save all of the fits into this fits 2. And I'm just extracting this fit every time I'm fitting it. So you can see there are 5 different model fits, 1, 2, 3, 4 and 5 different model fits. And then I basically use the MI combine to combine all of the fits, and then I use the summary function to extract all of the log odds. So the last point that I want to make is that we already knew how to do the logistic model fit in one data. Why do we need to do it in a step-by-step fashion, which is more work, right? The reason is that when we need to do more than just fitting a logistic regression, say for example in this case I'm using a step function to try to get a stepwise fit of each of these data sets one at a time. So I'm doing all of these steps one at a time so that I can get 5 different models out of all of these steps. Interestingly, when I fit all of these models, I saw that none of these variables are unimportant. So all of these variables were important and all of these variables were retained in the model. But this is just an example to show how we can break it down so that we can incorporate multi-step process inside the multiple imputation. So as you can imagine, from this example you can imagine doing even the matching in this way, where you have your analytic data, and based on that analytic data you can do all of your propensity score matching, and then when you get the match you can do your design, you can do your subsetting, and then you can do your outcome modeling, and then you can save your outcome modeling. And then once you have all of the fits, outcome model fits saved in a particular list, then what you can use is you can basically utilize the MI combine function to get all of your results like this way, MI combine to get all of your results. So it does not matter whether your process is one step or multi-step. When you are dealing with multiple imputation, you can basically do it by using this multi-step for loop and saving all of your result in a list. Rest of them can be done pretty easily. The summarization part can be done pretty easily.